So welcome to this already sixth webinar. Today will be on brewing low alcohol beer. But before I start, I will shortly introduce myself. I'm Gino, been with Fermentis for 3.5 years. Have before worked only in academia, so I have quite a strong academic background. More important, I'm passionate about fermentation and in particular making beer. So I have quite a lot of expertise in that. Today, again, I have Martin and Eric with me from our distributor, Caldic, the distributor in Scandinavia. So Martin, Eric, if you please take a moment to introduce yourself.
Yeah, I'll give it a go first. Thank you all, obviously, for attending Gino's webinar, our webinar, and thank you a lot to Gino for setting all this up and doing this series. As Gino has mentioned, this is the sixth in a series of 8. Today, concentrating on the LA01 and low no alcohol. I've been with, my name is Martin, as Gino said. I've been with Caldic for the past 4 years, selling brew ingredients in all of Scandinavia and the Baltics. Together with my colleague Eric, we'll try to act as moderators during the webinar. So if you have any questions along the way, just feel free to put them in the chat, and we'll either answer them directly or reach out to Gino to have him to answer all your questions. And even after the webinar, please give us a call or send us an email if you have any questions regarding the webinar or any of the other products. Eric?
Yeah, my name is Eric, working for Caldic in Norway for 3.5 years, almost, selling brew ingredients in Norway. Yeah.
Take it away, Gino.
I'm having some internet difficulties already for 2 days. I'm not sure. So if you lose me along the way, just put it in the chat because that was still working, and I will then get out and reconnect. So today I will talk about brewing low alcohol beer with a yeast that we specifically selected after quite an extensive screening process. I will explain you all about this process in the coming slides. But before I do, I'll just shortly introduce Fermentis again. So Fermentis is based, I'll get my pointer out, is based here just across the border with Belgium in the north of France. Actually, the headquarters of the Le Saffre group is in this region. It's a nice city with a great beer lineup. So if you are interested, you can always visit it. Our factory, where all the brewing yeasts are produced, is actually based in Ghent, in Belgium. It's only a 40-minute drive from the headquarters. Once in a while, we open the factory for visits. Actually, in the current situation, obviously not, but. When it's time, Eric and Martin will inform you, because then it's possible to come over and visit the factory. So what is Fermentis doing in the Le Saffre group? Fermentis works for the world of fermented beverages, beer, wine, cider, spirits, and any other potable alcohol. A good example is, for instance, hard seltzer, and we are getting a lot of questions about this. We have also new products. I think early after this cycle of webinars, I will try to organize a webinar on the production of hard seltzers, because it seems a lot of you guys are into it. Today I will again focus on yeast. As mentioned, we also have bacteria and yeast derivatives in our portfolio, but they will be discussed in the next webinar. So if you focus just on the yeasts in the tree of life, you can also build a yeast tree, as I explained before. The distance of the lines is actually telling you how far yeasts are apart, and also where the common ancestor is of a certain clade of yeast. So if you look at this group of yeast, the ones on top, the Cerevisiae, Paradoxus, Picate, Baianus, these are yeasts that are in generally used for brewing and also for making other fermented beverages like wine. Baianus is used a lot in wine. Mikata is used a lot in sake. And as you go along, you can see that there's a vast diversity, but still quite strong relationships between all these different yeasts. And as you will see, and why am I explaining this, is that there's more and more a trend of using the more non-conventional yeasts in producing, fermented beverages, and LA01 is actually one of them. Well, we thought at start, but you will see it's not the case. So if you look to studies done in literature, you see that there are two important studies that came out recently. So this is a study done in Leuven from Brigida, who basically sampled a lot of yeasts from industry, but also from different parts of the world, and sequenced the genomes and then checked, okay, how related are they? And they discovered quite an interesting thing. They discovered different groups. So a lot of yeasts seem to cluster in terms of the type of beverages. So you have a group of beer 1 and beer 2. You have a group that belongs to the wine yeast. You have a mixed group. And then they also found that the domestication could also be traced back. So you have yeasts that are typically found in Britain. You have yeasts that are typically found in the US and in Belgium, and also yeast from Asia. So this is quite interesting that it's both the beverage, but also the place in the world where these beverages are produced. Those yeasts have been basically optimized to work in that kind of an environment. So in this a little bit later, but quite close, another study came out which exactly did the same. So they were probably competing a little bit, and the results were quite similar. So they also find domestication aspects. So they find specific yeast, for instance, that only exist in the Philippines, and they also found different yeasts and different groups, like yeast that only came back in the beer, yeast that came back mainly in the sake, etc. So at Fermentis, we did the same, and I will show you in a minute, because there's also another way of looking at, okay, what are the specifics of certain yeasts without going into genomics. And this is more that, the classic approach. So if you look at a bunch of yeasts that are shown in this table, you have some yeast, the yeasts that are mainly used for fermented beverages, that are able to produce quite a high amount of alcohol, like the Saccharomyces baianus, which is the wine yeast, Cerevisiae, which you all know, is the top fermenting ale, the Pastorianus, Paradoxus. So these are all yeasts that are able to produce high amounts of alcohol. And then, with the whole low alcohol trend going on now, you see that people are more and more moving towards yeasts that are not able to produce these high amounts, but fairly lower amounts of alcohol. Some well-knowns I will also show, like the Pigia is used a lot, also for production of low alcohol beers and others. So if you look at the classic brewing strains, the ones I discussed before, we have the Saccharomyces pastorianus, the hybrid yeast, which prefers somewhat colder conditions, or actually is able to ferment in colder conditions, and that's why the fermentations are slow. And then you have the ale yeast, the Saccharomyces cerevisiae, which are top fermenting yeasts, normally prefer warmer temperature, or at least fermented at warmer temperature, and that's why these fermentations are faster. So at Fermentis, if we look at our current portfolio, we have 15 active dry yeasts now, 3 lagers, and the others are ales. We have a special range of yeasts, which we call SAF Brew, and that the reason we call them SAF Brew is because they don't fit in the SAF Ale or SAF Lager category. So these are more specialized yeasts. The LA01 I will discuss today. We have the HA18, which is used to produce beverages like barley wine, so very. Hello, am I back again? I changed some plugs. Oh, thank God! I changed some plugs, and I should be now on a physical connection instead of Wi-Fi. Maybe that was the problem. So I don't know where you lost me. Probably on this slide. So I'll just continue. I was mentioning. Okay, good. That we have a DA16, which I discussed last week. It's quite a new yeast actually, or a yeast enzyme mix to produce a brut IPA. I'm getting a question from Todd. What is F2? It's a SAF Ale F2. It's a yeast specifically designed for bottle re-fermentation. So if you add this yeast, it will not add a lot of additional flavor, or actually not at all. And secondly, this yeast settles really nicely and sticks to the bottom of your flask. So if you pour it, gently, like you always should with bottle re-fermented beers, you will not pour the yeast, which actually is never allowed. Just to me being very close to Belgium, you should always remember that if you want to stick to the official protocol, I would say, if you want to pour a bottle re-fermented beer, you always have to pour it clear. So you have to pour gently, and then the yeast. So you leave, like, say, 0.5 centimeter of beer in the bottle. Then you swirl the bottle to dissolve the yeast, and you have to pour that in a separate small glass and serve both. So the customer can decide to add or not to add the yeast to the beer. You can also drink the yeast separately because, as you all know, yeast is very healthy. It's full of minerals and vitamins. So there's no issue there. But it's just a matter of appearance. So bottle re-fermented beers should the classic ones like triples and blondes should be clear. Then we have 2 bacteria now. So we have a new one, SAF Sour LB1, which will be put on the market very, very soon. It has just been launched officially this week at the VLB World Seminar. There were some. I'm not sure any of you participated in that, but there were some lectures on it. So the LP652. Am I now back or not? Because for me it's a bit unclear. Okay. So the LP652 is I will explain next week, but it's a homofermentative lactic acid bacteria, which means it mainly produces lactic acid, while the SAF Sour LB1 is a Levi-Lactobacillus brevis. It's a heterofermentative lactic acid bacteria, so it also produces a little bit of acetic acid, a little bit less lactate, so lactic acid, and it can also even produce a bit of alcohol. But I will do a webinar on this one later. Then we have some functional products. Spring Blanche is one of them, but I will discuss Spring Blanche in 2 webinars. I think it's the last one in the cycle. So going back to the genetics and the diversity, I've shown this slide before, and I'm showing it again, just to show also later on where LA01 is actually positioned. So we have quite, in our current portfolio, if you compare it to what was in the literature, we have quite a nice diversity of yeasts in our current portfolio, not only in terms of yeast for different styles, but also in terms of genetic background. And some cluster, just as an example, PE134 and WBO6, both of positive yeast, both diastaticus, and they cluster nicely in the same group. And as you can see, they are quite distant from yeast like USO5 and SO4, which are further away if you look at the genetic distance. Some are closer, like the T58. T58 is closer because this one is also a positive yeast, but it's not a diastaticus. So you see that there's sometimes some agreement in the data. So let's go to quickly to the alcoholic fermentation in the brewery. So you start with the malt, where you do your mashing process to create fermentable sugars. If you use a traditional scheme, normally the composition is somewhat like this. So 10 to 15% glucose, 50 to 60% maltose. You have some maltotriose, and the rest are dextrins, which are unfermentable. But depending on the mash scheme, you can obviously change this composition. So if you mash in at high temperature, you will end up with a higher amount of unfermentable sugars. If you use like the maltase scheme, for instance, you will end up with more glucose, up to 30% or even 35, instead of the 10 to 15. So you can play with it and also basically decide on the fermentability of your wort. So then you do fermentation, and that's shown here quite, in a glucose or the CO2 and alcohol. This is a 1-to-1 ratio. Am I gone again? Okay, 1-to-1 ratio. If you look at it very closely, you can calculate and find out that on average around 5% of the fermentable sugars is actually converted into biomass. So if you look, what else is being produced, so this is all in the gram per liter range. Ethanol and CO2 are the most, but also in the gram per liter range is glycerol. Glycerol adds mouthfeel and some viscosity to your beer. It's an important compound. Then you have some acids, which are, can be in the gram range, but normally a lot lower. So I would say maybe 10, maybe 100-fold, depending on the acid. Then you have around 5% of the, as I mentioned, of the fermentable sugars turns into biomass, and then you have aromas. And aromas, you have to think in order of magnitude of ppms or even ppbs. So if you compare it to ethanol, it's like 100,000-fold less. But that doesn't matter because our receptors in mouth and nose are very sensitive, so we can actually pick up these very low trace amounts. So if you look at the yeast flavor metabolism, this is a simplified version. So you start with sugar, which is taken up by the yeast, then goes through glycolysis, or the Embden-Meyerhof-Parnas pathway, as it is called officially, through pyruvate, and then you go to produce ethanol, but also all kinds of interesting flavors. So two of them that are always produced are azo-amyl acetate, which are acetate esters, and ethyl acetate. Very important ones. Typical fruity banana is isoamyl acetate. Somewhat less appreciated is ethyl acetate, but in combination they were great. If you have too much of this, your beer will taste too solventy, it will smell like nail polish. In wine, for instance, this is actually an off flavor. In beer, it's not so much an off flavor, because if you specifically think on, like a triple or a complex beer, these two are very important and they contribute a lot to the flavor. Now, then also you have some off flavors. I will not go into details now, but one important one is 4VG. It's 4-vinyl guaiacol or 4VG-like compounds, because you have more than just 4VG that can be produced by yeast. It's like the clovey note, the spicy note that you get in typical Belgian-style blonde beers, for instance. And it's caused by ferulic acid, which is present in barley and in wheat. And then the yeast, so this ferulic acid can be converted by the yeast in this compound 4VG. And the threshold is quite low, so you can pick it up quite easily. The yeast that can do this are the so-called POF-positive yeast, so they have the genes that are able to convert ferulic acid into 4VG. So to make a little bit of sense of what our yeasts are capable of, we made this nice diagram, which is based on the yeasts are fermented in all the same conditions, multiple times actually, at least 3 times. And then we did an extensive sensory analysis and came out with this final image with 3 axes: neutral, fruity, and spicy. and we positioned the yeasts based on the flavor profile when using these specific conditions. So they're all the same for all yeast. So if you want to brew and you know, want to find out which yeast I should use, you can go along the fruity axis and select one of the more fruity yeasts. If you want to make a neutral yeast, you can go along the neutral axis. And this is standard. So we call this baseline diversity, because as I showed in the third webinar and also the fourth, these things can move around depending on the conditions. And then on top of that, if you add hops, you have now back? Okay, sorry guys, this is really annoying. I'm not sure what's going on. So now let's focus on non-alcoholic beer, because that's why you're here for today. So if you look at the non-alcoholic beer market evolution in the past years, that's shown here on this slide, it grew from 13.5 billion to more than 25 billion over the course of 8 years. And for the coming years, they expect a growth of at least 7.5%. So, you know, if you are a craft brewer and want to get involved in new types of business, this is something that you really should have in your portfolio. More and more people are aware that alcohol is not that healthy for you. At least if it's also depending on obviously the amount that you consume. But there is a strong trend in especially on the younger people that want to have more healthy drinks, including low alcohol beers. So there's a big market for it, and it will grow the coming years quite significantly. So obviously we noticed this already a few years ago, because we started with the LA01 project already in 2016, and the first results came out already in 2017. And I'll take you along how in this development project in the coming slides. So we selected in the end Safbrew LA01. It's a maltose negative strain. It produces some aromatic compounds, and it produces a very low amount of phenolics. But how did we I'm going to try to switch. Now back? How annoying this is. I don't know where you lost me. Did I lose you on this slide or? Okay. Oh, you heard this slide. So perfect. I'll go to the next one. So if we go back, you know, to the phylogenetic tree we have for Fermentis yeast, then we find the LA01 is actually here. So LA01 is a Saccharomyces chevalieri. That was the name back in 2016. It was denominated Saccharomyces chevalieri. So if you think back a few slides on, you know, the more non-conventional yeast, this was one of them. Chevalieri is also unconventional yeast. But as you might know, in naming of the yeast, that there's a constant evolution. So they reclassify, you know, based on all kinds of information that becomes available. And actually, this yeast, the Saccharomyces chevalieri, was reclassified in early 2019 or end 2018. It doesn't really matter, but it has been reclassified to a Saccharomyces cerevisiae variety Chevalieri. So it actually belongs to the Cerevisiae, but it's a special variant. So if you look, where does this cluster? It's actually clustering in the sake clade, which is quite interesting because apparently it's quite close to HA18, which is the yeast, as you know, to produce high alcohol beer. So apparently there's only a few differences between these two that enables or disabled actually the maltose transport in this yeast. It's quite interesting from a genetic perspective. So what we did to start, first, obviously, we compared the LA01 in a screening. So we did the screening actually, including LA01. We looked at Pichia kluiveri, Saccharomyces ludwigi, Torrella del Bruchi, Zygosaccharomyces rucci. These are the more common yeast to produce low alcohol beers. And we fermented it in 100% Pilsner malt in the mass diagram, 65 degrees for 50 minutes and 73 for 10 minutes, so quite high fermentability, making a 12 Plato wort. We used 25 IBU bittering using mosaic hop pellets in this case. And then we diluted back to 8 Plato and 16 IBU to reach a target of 0.5 ABV. So this is something, this practice is done a lot also in professional breweries, in industrial breweries, where they make more high gravity wort and dilute it back to lower the fermentability. The temperature of fermentation that we tested this initial experiment was 22 degrees, but later on we also did some experiments with LA01 on 10 degrees, and I will show these results later. So let's look at the final ABV first of these different strains that we use. So on this graph, you see on the y-axis the alcohol percentage, and on the x-axis the different strains. So this is end of fermentation, and which were done at 22 degrees in this case. So the first one you see, Torrella got around 1.1 ABV, the Ludwigi also around 1.1, the Rucci around 0.7, I would say, and then the Pichia around 0.8, and the LA01, which was first called Saf Ale. It was renamed in 2019 to just make sure that people understand that this is not a normal ale yeast. It also fermented to around 1% as expected. So you see some heterogeneity in the data. The Torrella and the Ludwigi actually are maltose positive yeasts, but they grow very slow. So they are able to take up maltose, but because they grow so slow, they don't convert all the maltose. If you think about that in a more practical sense, you might end up with some issues in terms of over attenuation, because if you bottle these and then leave them standing around for a while, you could still have additional fermentation. Then we looked at the Rucci and the Pichia. They very nicely consumed the simple sugars, but not all of them. So they produced quite sweet beers in general. Obviously, as you understand, all these low alcohol yeast produce quite sweet beers. Then the Saf Ale as last, it stopped after consumption of the simple sugar, so the glucose, fructose, sucrose, and did not ferment maltose. So there was, we said, okay, there's a little bit less risk of over attenuation. Then obviously we looked at the flavor profile, which is most important. The Torrella Spura, the Del Bruchi, produced a neutral malty worty beers, quite nice profile. The Ludwigi, also quite the nice balanced fruity beer with a, but that can be caused by other issues. The Rucci, in our analysis, produced a lot of off flavors, so it was not nice. The Kluiveri produced a very fruity beer with an extreme high level of isoamyl acetate, so the banana, and to our,
Hi, everybody. I'm just curious. Do I get through to you? Can you hear me and see me? Ah, perfect. Perfect. I just talked to Gino on the phone, and unfortunately, the entire area he's in, the internet connection is down. So unfortunately, we have to reschedule this webinar because Gino, he's not able to get back in. And he just talked to his service provider, and there's nothing they can do. It'll be at least a couple of hours, and at that time, we've probably all ventured on to something else. So sorry, guys, no webinar today on the LA01, but as soon as possible, Gino and I will get back to you with a new date and time. In the meantime, please, please go out and have some of your local breweries' beers and ciders, and have a nice weekend, everybody. Sorry for the inconvenience. Bye, guys.